Hi guys, welcome to this page of the notes. We said here in this section, this set of videos, we're going to talk about two new figures. The kite, which we already talked about on the previous page, and now the trapezoid, which we're going to talk about here. Now, what we said previously was that a kite is a quadrilateral, but not a parallelogram. I then told you that a trapezoid is a quadrilateral, but also a parallelogram, and that was not necessarily entirely true. Here's what I mean by that. So when it comes to a trapezoid, here's what we've got. A trapezoid is a quadrilateral with one pair, at least one pair of parallel sides. Now, that is more like a parallelogram than a kite, but does that make a trapezoid a true parallelogram? No. So remember, a parallelogram must have two pairs of opposite congruent sides. Two pairs of opposite congruent sides, and for a trapezoid, we only need one. So yes, a trapezoid is a quadrilateral just like a kite. But a trapezoid is not a true parallelogram because in this case we only need one pair of parallel sides. The parallel sides we're going to call the bases of the trapezoid. That's what I tell you right here. So the parallel sides are called the bases of the trapezoid. The other two sides, which won't be parallel, are the legs. All right? So you have the bases, those are the parallel sides, and then you have the legs, and the legs, lots of crazy stuff can happen with the legs. Now, I have two different pictures of trapezoids here. That is because we're going to take a look at a very specific type of trapezoid. So when it comes to a trapezoid, really the only stipulation for a trapezoid is simply this. You only need one pair of sides to be parallel. They don't have to be congruent, right? Nothing is said about congruence. They just have to be parallel, and so you can wind up with some really crazy looking trapezoids. What we're going to look at here, well, the ones we're going to spend time on are these ones right here, the isosceles trapezoid. And here's why we're going to spend time on those. First, the parallel sides are the bases. But one additional piece of information about a trapezoid that is an isosceles trapezoid, and it's this. The legs, they're not parallel, but they will be congruent. So, in an isosceles trapezoid, the legs are congruent, but not necessarily parallel. So those are the types of trapezoids that we're going to spend most of our time looking at here. The ones we're going to do example problems with, we're going to have the base sides of the trapezoid, those are the parallel sides, and then the legs. The legs won't be parallel, but they will be congruent. And let's take a look at the properties of these isosceles trapezoids, which I've got for you right here. So let's go ahead and take a look at these. There are three of them. We'll highlight them as we go through them. First, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So the base angles will be congruent. We'll see that here in a second when we start looking at some problems. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. This is really interesting and actually a condition for proving that it's a trapezoid. If you can show that a pair of congruent base angles, or if you can show that a pair of base angles are congruent, then you know it must be an isosceles trapezoid. And then the last one I've got for you here, a trapezoid is isosceles if and only if, interesting, its diagonals are congruent. So we're going to use those properties and theorems here of trapezoids to answer some questions. Let's go and take a look at these guys right here. I'll leave those properties right there so that you can see them. And here we go. I want you to find the measure of each value first, based on the diagram. Please notice that I have one pair of parallel sides. Those would be my bases. That's a base, and this is a base. But that's not enough. In order for it to be an isosceles trapezoid, the legs have to be congruent. Are they? You bet they are. I tell you right there that those two opposite sides are congruent, and since those are my legs, I now know that I have an isosceles trapezoid. Oh, sorry, don't want the C yet. There it is. I have an isosceles trapezoid. And please remember that an isosceles trapezoid has congruent diagonals. That is one of my properties of isosceles trapezoids right here. If the trapezoid is isosceles, which I know it is, I just showed that it is. If the trapezoid is isosceles, then the diagonals are congruent. So here we go, let's take a look at the information given. I am told that AC is 13.2. So right here in green, AC is 13.2. And BE is 8.4. BE is 8.4. In yellow, BE, right there, there he is right there, BE is 8.4. What I want you to do is I want you to find DE. Well, this really is just an algebra problem that we can set up very, very quickly. I know that the diagonals have to be congruent, which means that AC has to be congruent to the entire other diagonal, BD. Okay, but hang on. I need to split BD up, right? Because I only know just that teeny little portion of BD, which is BE, and then I'm asked to find ED. So let's split this up into its two segments. AC is congruent to BE plus ED. I'm told BE, it's 8.4. I'm asked to find DE or ED. Well, let me go ahead and switch them around so that it looks like what I asked you for. I asked you for DE. No big deal. We just switch those around. There it is. Find DE. Well, guys, plug and chug. Don't fat finger something on your calculators. Should be pretty easy. 13.2 has to be equal to 8.4 plus whatever DE is. Well, subtract the 8.4 to the other side, and DE must be equal to 4.8. Has to be. Why? It's an isosceles trapezoid. The diagonals must be congruent, so you find the little piece that you're missing. Let's go ahead and try another one. Here's what I got for you. I ask you to find the value of x so that the trapezoid that I've given you is isosceles. Okay, so I want this trapezoid to be an isosceles trapezoid. Here's what we remember about isosceles trapezoids. Here are my parallel sides. I tell you that right there in the diagram. There they are right there. Those are going to be my bases. Now remember, one of the properties of isosceles trapezoids, in fact, let me slide back up to it, right here. I tell you, the quadrilateral is isosceles trapezoid, then each pair of base angles are congruent. Slide back down. If this is going to be an isosceles triangle, what do I know then about this pair of base angles? Let me put them in green there so you know which two I'm talking about. This one and this one. Well, the property simply tells me if this is an isosceles trapezoid, those base angles have to be congruent. They have to be. So, set them equal to each other, solve the algebra problem. That means that angle F must be congruent to angle E. All right, well, we start throwing stuff in there. Angle F, 2x squared plus 21. Angle E is a 3x squared minus 4. All right, let's go ahead and do a little bit of algebra. I will subtract the 2x squared to the other side, add 4 to this side. So I wind up with 21 plus 4 equals 3x squared minus 2x squared. What does that get me? That gets me 25 is equal to an x squared. How do you get rid of a square? Yeah, take the square root of both sides. Take a square root, take a square root. Don't forget to do plus or minus. Every time you take a square root, you got to do plus or minus that value. So I wind up with x is equal to, what is the square root of 25? Well, the square root of 25 is 5, so I wind up with a plus or minus 5. My question is, I get two answers. It could be a plus 5, it could be a minus 5. One of those is right, one of those is wrong. Which one is wrong? Well, if you were to go ahead and make, actually, here's why you wind up with a plus and a negative 5. Please notice that we're squaring something, all right? So here's what I want you to take a look at. If I do a positive 5 squared, and if I do a negative 5 squared, what do you get? You get the exact same answer. A positive 5 squared is 25, but a negative 5 squared is also 25. So what this means is find the value of x so that the trapezoid is isosceles. You get two values of x. It could either be a positive 5 or it could be a negative 5. Plus or minus 5. All right, what we'll do on the next page of notes is we'll take a look at a couple more problems dealing with trapezoids. I'll meet you there.